Okay, let's start our lab fifth. So what you have to prepare in this lab? In lab fifth, first of all, the use of micrometer screw gauge. In this, you have to go through all this theory. This is the same theory you did in your college, but a bit in detail. So what are the principle? What is the principle of the screw gauge? Question can come from is that write down the principle of screw gauge. Not that simple, but maybe I will ask about the construction or the parts of the screw gauge. So you have to read and remember all these parts which here defined: A, B, C, and these all nuts and main scale, and here is all the detail for this, what this part generally do. Then about the least count, you have to remember this formula, because in our next lab, in lab 6, we will do some numericals related to least count. Secondly, about the zero error, what is zero error and types of zero error, like positive zero error, negative zero error. And finally, the use of the micrometer screw gauge. So for this lab, you have to learn all this by heart. You should know what is the principle of the screw gauge, what are the parts of the screw gauge, what are their functions, what is least count, what is zero error and the types of zero error, and finally the use of the screw gauge, how we measure from the inside and from the depth, because we will not be having screw gauge and measuring equipment, but in theoretical you should know and you can write. And finally the last question, that will be industrial application of the screw gauge. You do this at home and keep it to you. If there will be a viva, then I will ask you to bring with you. Otherwise the question can come in the exam also about the industrial applications of screw gauge. So this was the lab 5, which is all theoretical. In lab 6 we will do the numericals for screw gauge, and here I gave, I think, 4 or 5 examples. These are the 5 examples, and same formulas are used. For example, let's take example number 1. In example number 1, it said that the screw of a micrometer screw gauge moves through a distance of 2 mm. When it is turned through 4 rotations, find the pitch of the screw. If the circular scale is divided into 100 equal parts, find the least count of the micro screw gauge. So let's see what is given. First thing is distance traveled by screw gauge. This is in the first line. Screw gauge moves through a distance of 2 mm. We have 2 mm. Now the number of rotations, that is when it is turned through 4 rotations, we have 4 rotations. Find the pitch of the screw gauge. So you have to remember this formula. To find the pitch of the screw gauge, the formula is distance traveled by screw divided by number of rotations. So distance traveled was 2 mm and the number of rotation was 4. So 2 mm divided by 4, answer is 0.5 mm. So the pitch of the screw gauge is 5 mm. So this formula you have to remember. So you have to remember this formula. Second thing is number of divisions on circular scale. This is another thing they said. If the circular path is divided into 100 equal parts, so it is 100, find the least count of micrometer screw gauge. So what is the formula for the least count? Least count formula is pitch of screw gauge divided by number of circular scale divisions. So what was the pitch? Pitch here we find by this formula, that was 0.5 mm divided by number of division, that is 100. So the answer is 0.005 mm. So hence the pitch of the screw gauge is 0.5 mm and the least count of the micro screw gauge is 0.005 mm. So in this numerical we find out that we have two formulas to learn. One is how to find the pitch of the screw gauge, and the formula is distance traveled by screw divided by number of rotations given, and the second formula is the least count of the micrometer screw gauge, that is pitch of the screw divided by number of circular scale division. So all the values were given in there, but you only need to remember these two formulas. Now let's move to the example 2. If the pitch of the micrometer screw gauge is 0.1 mm and its circular scale is divided into 100 equal parts, find the least count of the screw gauge. So pitch is already given here. Here what we learned that when we were finding the least count, we need to have pitch and number of circular division. So here we find out pitch, but in the second numerical they already give the pitch, that is 0.1 mm, and the second thing is its circular scale is divided into 100 equal parts. So 100 is also given, the number of division of circular scale. Now we have to find the least count, and least count formula was pitch of the screw gauge divided by number of scales. So that is 0.1 divided by 100, and the least count is 0.001 mm. So here also you only need to remember the least count formula. Let's move to the example 3. If the pitch of the micro screw gauge is 0.1 mm and its circular is divided into, find the correct reading for reading as shown, the non-zero error. So here we have to find this. So what is given? First we list out that 0.01 screw gauge pitch is given. You can write 0.1 centimeter or 1 mm. The number of division is, that is given 100 parts, and here it is 100. So least count of the micro screw gauge is what? Pitch of the screw gauge, that is this, and number of circles, that is 100. So 0.01 mm we get the least count. Now the main scale reading 4.5 mm. I think for this reading we need screw gauge. So we can, the example where we need the screw gauge, we can eliminate that. So we can skip this example from our, I will also skip this in your PDF file. So we will do example 4, because here we need the screw gauge and we can't do experiment practical here, so we will go to the formula examples only. So now move to the example 4. When a screw gauge with at least count of 0.01 mm is used to measure the diameter of the wire, the reading on the sleeve is found to be 0.5 mm and the reading on the thimble is found to be 27 divisions. What is the correct diameter of the wire if the zero error of the gauge is 0.005 centimeter? So what is given? Least count is given, that is 0.01 mm. Main scale reading is also given 0.5, and what more thing is there? Circular scale reading is also given. Reading on the thin line is found, that is this means circular scale reading, that is also given 27. So what is the correct distance of the wire if the zero error of the gauge is positive 0.005? So first we have to then what reading is showing, and for that we have to use this formula MSR, CSR, these are plus